So, looking at the last slide or the last part of the session over here, we'll look at the derivative of a function. It's just talking about the rate of change, the average rate of change, or what is called a difference quotient, right? So, this explains how fast y changes with respect to x. And we use this this is found by using a limit, right? So we are looking at how fast y, right, changes with respect to what? X, right? So think of it like this. If you zoom in close on a curve, right? If you zoom in close on any curve, the slope at a point becomes clearer, right? That slope is a derivative. So if you zoom in really close on a curve, the slope at that point on a curve, right, becomes clear. That slope is the derivative of the function, or is the derivative of your given function. Or we could say that the derivative is the exact rate at which a quantity changes, found by what? Zooming in infinitely, right? Infinitely close and taking the limits of the change ratio. I'll take it again. It also means that the derivative is the exact rate at which a quantity changes, found by zooming in infinitely close and taking the limits of the change ratio. So most times we are interested in the rate of change of y when change in x is very small. So how fast is this y going to change with a change with respect to this x, right? How fast is this y changing with respect to this x over here? So in such cases, it is possible to obtain a change in y over change in x, which is the average, by dropping all terms of the change in x in the difference quotient formula, right? For the last time, we'll look at this. It says that, for example, in the last example that we did, right? If change in x is very small, then the change in y over change in x is approximately 6 by 30, right? It's approximately 6 by 30. So saying that if we had this initial value of x to be 5, then we had no value here for the change in x. It means that the value of the change in x is very small. It could be 0. So say this is 0, change in x here is 0. Then we are left with 6, right, by x0, which is 5 here, plus 3 multiplied by 0 over here, that to give us 0. So 6 by 5 is approximately what? 30. That is what this is trying to say, right? For example, if the change in what? X is very small, right? Then the change in y over change in x is approximately 6 by 5, which is equal to 30. The smaller the value of change in x, the closer is the approximation of what? Change in y over change in x to the true change in y over change in x. So the closer the value of this, assuming it's 0, we would have this being equal to or being approximately 30, which is very true to the average, right? As the change in x approaches 0, meaning that it gets closer and closer to, but never really reaches the value 0. So 6x subscript 0 plus 3 change in x will approach 6x to the subscript of 0, right? That is the 6 by 5 giving us the 30. So symbolically, this statement is expressed as change in y over change in x approaching 0, or change in x approaching 0, or by the equation. You see, I said that we find this, or explaining how fast y changes with respect to x, it is found by using a limit. So we say the limit of the change in x approaching 0. That is the change in y over change in x. It is 6x subscript 0 plus 3 a change in what? X. But you can see that here, you see that the limit is such that change in x is approaching 0. So wherever we have change in x, it's going to be replaced by the 0 automatically. Let's put it in that way to make it very simple and clear. So that will be 6 subscript 0 plus 3 times 0. And that will give us 6 subscript 0 here, right? So the symbol LIM represents your lim. That is change in x approaching 0 is read as the limit of change in x, right? The limit of the function as the change in x approaches 0, right? So the limit of that given function as the change in x, right, approaches 0. If as so say change in x approaches 0, the limit of the difference quotient change in y over change in x exists. That limit is identified as the derivative of the function y equals f of x. That's what I was saying. So if that change is being really looked closely, right? You zoom in really close on that curve or on that limit that's identified, the slope at that point becomes clear, right? And then that slope is what we call the derivative of the function, right? So the slope on that curve becomes the what? At that point becomes the derivative of the function. So we would say y equals f of x, or f of x is equal to y, right? Thank you. See you another time.